So now that we've explored the different concepts of working load limit, minimum breaking strength, and safety factor, we want to start looking at the individual connectors that go into it and how it's applied. So in front of me right now is I have a couple of different styles of shackles. We have bow shackles, D shackles, and twisty shackles. You know, all of these can be gotten from multiple different sources, but it's really important to make sure that you're getting quality hardware from a trusted source. Okay, so I'm going to start off by talking about the bow shackle. You know, this is a giant example right here. Bow shackles, interestingly enough, are designed for tri-loading. So in the scenario with the carabiner, you know, that's one example where you don't want to tri-load. Whereas with a bow shackle, it's entirely appropriate, and it's actually designed to do that. So with the bow shackle, you can apply a load downward off the green pin here, but then also have multiple vector loads coming out from either side. So this is an appropriate, you know, the bow shackle is an appropriate connector to be used under a tri-loading condition. When we move into the D shackle, these are meant to be loaded linearly. They come in multiple different sizes, captive pins, non-captive pins. One of the cool things about the captive pins is when you undo the pin, they don't fall out. You know, that's one of the small drawbacks with the shackles is sometimes the pin can fall out. But you know, it's just something that we deal with from time to time. The third type of connector is a twisty shackle, and these are really great because you can actually rotate something 90 degrees from, you know, something else. Let's say if you're trying to cross reeve pulleys or set something perpendicular to something else. These are great for that particular use. And they also come in multiple different sizes. Okay, so when you're actually going and trying to determine which of these would work best, you know, you want to look at the shape and the design of it, but then you also want to look at the load ratings because different shackles are probably going to take different loads. Okay, typically loads are stamped on the side of the connector, like this Van Beest. This one's stamped with a 2-ton working load limit. So if we apply a safety factor of 5 to that, which is an industry standard, that gives us a minimum breaking strength of 10 tons. So it's a safety factor of 5 applied to this guy. Okay, that's a pretty common standard, but it's good to check from the manufacturer or the retailer to make sure that's constant. When you start getting into this stainless steel stuff, oftentimes there's nothing stamped on them. So again, going back to the retailer, going back to the manufacturer and finding out, you know, what the actual loads are that this little connector can take, because it's really important when we're talking about load cycles and, you know, strength of the overall system. When we start looking at bringing these connectors close or beyond the working load limit, you can actually deform the device or the connector slightly. So when you start going above that working load limit, that's why it's applied, is you can start deforming the connector and making it somewhat inoperable. So if you ever run into a condition where it's really, really hard to take your shackle pin out, like you can't get it undone for the life of you, even if you applied a little bit of mechanical advantage to it, you've probably deformed or overloaded the shackle and you should not use it after that. Okay, so that's just a quick check to make sure whether or not you've overloaded your connector, as if you can't get it undone. Okay. So these are a couple different, you know, really common forms of shackles within slacklining, and yeah, it's up to you to decide which is going to actually work best in your particular scenario.